In this figure, we have the triangle CDE inscribed in a semicircle, and we need to find the length AB. We are given that AE is 14 units, ED is 48 units, AB is perpendicular to CD, and B is the center of the circle. First, it's important to know that the triangle CDE is a right triangle and angle E is the right angle. And this is because this angle is an inscribed angle in a semicircle, and such an angle is always a right angle. Now, in this figure, we see that AB is a side of the triangle ABC. So, if we would know side BC and the hypotenuse AC, then we could use the Pythagorean theorem to find side AB. To find these two sides, first we will connect the points A and D, and we will form the right triangle ADE. In this triangle, one side is 14 units, the other one is 48 units, and we can use the Pythagorean theorem to find the hypotenuse AD. The Pythagorean theorem tells us that in a right triangle with the legs A and B and the hypotenuse C, A squared plus B squared equals C squared. So then we will use the Pythagorean theorem to find the hypotenuse AD. So we will write 14 squared plus 48 squared equals AD squared. Then 14 squared plus 48 squared is 2500 equals AD squared. Then to find AD, we will take the square root of 2500. Then AD equals 50. And now in this figure, if AD is 50, then AC is also 50. And this is because the triangles ABC and ABD are congruent. They both have right angles. Side BC is the radius of the circle, and it's equal to side BD, and side AB is the common side to both these triangles. So far, we found the hypotenuse of the triangle ABC, and to find side AB, we still need to find side BC. And for this, let's take a look at the triangle CDE. In this triangle, side DE is 48 units, and side CE is 50 plus 14, which makes 64 units. Then we can find the hypotenuse CD using the Pythagorean theorem. So again, DE is 48 units and CE is 64 units. Then 48 squared plus 64 squared equals CD squared. On the left side, 48 squared plus 64 squared makes 6400. All this equals CD squared. Then CD equals square root of 6400. Then CD equals 80. And now BC is half of 80, and that is 40. And now in the triangle ABC, we know side BC, the hypotenuse AC, and we can use the Pythagorean theorem to find side AB. So then, in this triangle, 40 squared plus AB squared equals the hypotenuse squared, which is 50 squared. In this equation, AB squared equals 50 squared minus 40 squared. Then AB squared equals 900. And then AB equals square root of 900, which equals 30. So we found length AB, and it is 30 units, and now the problem is completed. Thank you for watching the video. Please subscribe, leave a comment, and please come back for more videos.